let's work this ACT math question. The question says that the parallelogram below has consecutive angles with measures x degrees and 25 degrees. What is the value of x? So we're looking for x, and when I look at my figure, I'm looking for this angle right here. And because we're given that this is a parallelogram, I can take the angle x and add that to the consecutive angle 25, and that's going to be equal to 180 degrees. So I'm going to subtract 25 from both sides, and I'm going to get that x is equal to 155 degrees, and that is answer choice E. So if you understand this question, great. You can move on to another one. But if you want a little bit more information on this type of question, I'll go into that now. Why could I say that these two angles, angle x and 25, add up to 180 degrees? Well, there's a little bit of information in this question that we need to be able to do that. And first of all, I said something about it being a parallelogram. That's what we're given in the question. Let's talk about what a parallelogram is. We know that a parallelogram is a four-sided figure, and another name for that is a quadrilateral. And a parallelogram is a special quadrilateral that has four sides with opposite sides parallel. So we can see that this side is parallel to that side, and then we have this side length is parallel to this side length, opposite sides being parallel. Now, because we know about this being a quadrilateral, a four-sided figure, or a four-sided polygon being a closed figure, we know that the sum of the four interior angles of a quadrilateral equal 360 degrees. And that's important for you to remember. A four-sided figure, interior angles equals 360 degrees. That could come up in several different kind of questions. Now, because the opposite sides of this parallelogram are parallel, there's another way we can look at a parallelogram as two parallel lines cut by a transversal. If you've been in geometry, you've probably looked at angle relationships related to two parallel lines cut by a transversal. So here are our parallel lines, and then we have our transversal right here, a straight line. Now, we learn a lot about the different angle relationships in this, and if you'll see, this feature right here looks a lot like the bottom half of this parallelogram. Now, in some geometry classes, you talk a lot about the names of the different angles in two parallel lines cut by a transversal, and that's great, and it's good to know because sometimes those type of angle names show up in questions and you've got to know what they're talking about. But it's not necessary for this particular question, but we'll still try to look at what these angles are called. Recall that when you have two parallel lines cut by a transversal, that the two interior angles, this angle here and this angle here, which in our figure is equivalent to x and 25, we know that these are supplementary angles, meaning they add up to 180. And that's what we ended up using. That's one of the properties that we were able to use to come up with our answer. Now also, note in general, we can look at our two parallel lines again, these two parallel lines cut by a transversal, which is very similar to our figure of the upper part of the parallelogram. Again, here now we have two angles, but they have the same interior relationship. They are supplemental to one another. And there's other relationships with the two parallel lines cut by a transversal. Remember, you have corresponding. So if we know this one that's marked with the double lines, it is equivalent to this angle right there. And the angle with the one line is equivalent to that one, the corresponding angle relationship. And there's several others. For this particular question, what we really wanted to make sure that we knew is this supplemental relationship but based on the interior angles of two parallel lines cut by transversal. In general, what you want to remember is for a parallelogram, when we have consecutive angles, they add up to 180, which really is the 360 degrees of the total interior angles of the quadrilateral divided by 2. And that's where we get the 180 degrees and the supplemental relationship. That's the relationship we want to remember when we're working with parallelograms. Again, there are other relationships with these angles we can see and explore that would result in the same answer. And it's great for you to explore these if you'd like to get some help and go deeper in your understanding. But we're going to stop right here for the purposes of ACT Prep. If you want to dig farther or look for more examples, search for the topics of angles with parallel lines, quadrilaterals, and parallelograms. This is your math question of the day. We have lots more videos to help you prepare for the math section of the ACT. Subscribe so you'll get our next practice. Until then, practice a bit more on your own, and when you take the test, you'll be glad that you did.